Okay, so we can use the integration to find the areas, right? For example, last time we discussed that by the definition, integration is the area under the curve, right? So here, if my curve is given as the f of x, if I would like to find the area under this curve in the interval between a and b, what does it mean in the interval? It means the x changes from a to the b, right? So in this interval, I just need to do the integration, right? So this area will be the integration of this curve from a to the b multiplied to the dx, right? You see, so dx means x is changing, right? X is changing from a to the b. This is what does it mean, this notation, okay? But the meaning of the integration, does the integration, is it possible that the integration is negative? The area cannot be negative, but the integration can be negative, okay? So yes, so because of the values of the function can be negative, okay? For example, if you would like to find the integration of the function which is below the x line, for example, your function is like this, okay? You would like to find, for example, this area, okay? So let's say if you would like to do this from a to the b, okay? If I say, hey, tell me what is the area, you cannot just integrate this function from a to the b, okay? So you have to integrate from a to the c first, then from c to the b separately, okay? The reason is like this. So the reason is the integration of the function from c to the b will be negative, gives you a negative value, okay? So the integration from a to the c gives you positive number. So now, could you please tell me why this gives you me the negative value? Why this part is negative? Because of the definition of the integration. Do you remember what we did in order to find the area here? We divided this into the many small rectangles, right? Right? So where the heights of the rectangles were just the value of the function at this point, right? For example, if this is x1, this is f of x1. Obviously, if f, your function, is below the x line, f of x1 will be negative value, right? So we said if I would like to find the area of this rectangle, the second one, I have to multiply the height, which is f of x1, right, with the negative number. Multiply this to the delta x, which gives you again negative number, right? So this will be negative for all the rectangles, okay? So if you sum them at the end, it gives you again the negative number, okay? So if the curve is below the x line, the integration is negative number, okay? So you need to understand it's like integration is kind of net area, okay? If your function is below the x line, it gives you negative value. If your function is above the x line, it gives you positive number. If I still ask you, find me the area between a and b, like a real area, you have to find this area separately by integration. You have to integrate this curve from c to the b separately. Then you need to add their absolute values. Okay? So is it clear? The integration means the area, but only in the case when it is like above the x. I mean, this is the same. Okay, so the module of the integration is the area. Okay? So if I say, hey, your function is given as, for example, as the sign. Okay? So do you remember how the sign looks like? So at the pi over 2, it is equal to the 1, at the 0 is 0, right? So at the minus pi over 4, pi over 2, it's also minus 1, right? It looks like this. If I say, hey, this is the function, f of x is equal to the sine of x. What is the area under and above this function from minus pi over 2 until pi over 2? What is the integration of the sine of x from minus pi over 2 until pi over 2 dx? What is this integration? Can you tell me by just looking to the image? They are symmetric. Okay, the function is symmetric with respect to the 0. With respect to this is 0. Okay, because this is the same area as this one in their absolute values, but this comes with the negative value. This comes with the positive value. Okay, so the integration of the sine will be equal to the 0. Okay, if I ask you, tell me what is the real area, you have to integrate this part separately, this part separately, and sum their absolute values. Okay? But if I ask you, hey, what is the integration? It will be equal to the 0. Okay? We can quickly check it, right? So what is the integration of the sign? So I can use the antiderivative of the sign, which is minus cosine of x, right? From minus pi over 2 to the pi over 2. If you put the pi over 2 to the cosine, it gives you 0. If you put the minus pi over 2, it gives you again the 0, right? So the answer is 0. Okay? So don't be surprised if you see this kind of picture and you will get the answer to be equal to the 0, okay? Because the integration is the net area, okay? So do you understand what does it mean net? For example, if you have some business, you have some expenses, outcomes, and you have some incomes, right? At the end, what you do is, like you sum the incomes and you subtract the outcomes, right? Your net profit will be like the thing which you have at the end, right? So net, right? So this is the same thing. Net area means you need to add the positive areas, you need to subtract the negative areas, as in your business, okay? Net profit means like the profit which is left after you have paid everything, all the expenses, okay? Good. Now let's talk about this thing. So what if I would like to do this one? So if I have two curves, this curve, for example, f of x, and another one like this, g of x. So what is so let me draw this differently. So what is the area enclosed by these two curves? Enclosed. Do you understand this word, enclosed? Right? Closed between these two curves. What is the area enclosed by these two curves? Okay? The only thing which you know is the functions, okay? Function f will be given using some formula, and function g will be given some formula, okay? So we're interested to find the area enclosed to this, okay? So from the engineering point of view, could you just tell me the idea, what I have to do? What is the idea of finding the area enclosed by this T? We have to again divide this area into the many rectangles. Okay? So let's make the rectangles. So for example, this rectangle, this rectangle, this kind of rectangle, and so on, right? And by finding the areas of each of the rectangles, and by summing them, we can find the total area. Yes?
Can you find by another method, for example, find area under the f of x minus area of g?
No, it doesn't work. Or, yes, it works. It works, yes. But this is the same thing, okay? You will get this answer like this as well, okay? So now, if I would like to find this area by making the rectangles. Okay? So is it possible to make the rectangles? Yes? Okay, how to find each area? So for example, let's say I would like to find the area of this rectangle where x is given, for example, as x1. Okay? What is the area of this second rectangle? So you split the area between A and B to the small subintervals, right? To the small subintervals with the width delta x. Do you remember? So delta x is equal to the B minus A divided to the n. Okay? Now, the width of each of the rectangles is equal to the delta x, right? Well, let me just copy this rectangle here. So let me copy this. So this rectangle is equal to this one, where the width is equal to the delta x, right? So what is this point? This point? This is g of x1, right? So what about this point? F of x1, right? Do you understand this? F of x1 tells me what is the height of the curve f at this point x1, right? So this is f of x1, this is g of x1. What is the height of this rectangle? Their difference, right? Their difference. So the height of this rectangle is equal to the f of x1 minus g of x1, right? And I have to multiply this thing in order to find the area. We have to multiply f of x1 minus g of x1 t is the delta x, right? This gives me only the area of one rectangle. So if I would like to find the total area between these two curves, we need to sum all the areas of the rectangles, right? So we need to write f of x1 minus g of x1 multiplied to the delta x. I goes from 1 to the n. So when we take the limit, n. So when we take the limit when n goes to the infinity or delta x goes to the 0, this gives us the integration of the f of x minus g of x dx. X changes from a to the b. Okay? This is the idea. If you would like to find the area enclosed by the two curves, just subtract them, integrate them from a to the b. Okay? So let's do an examples. But the idea is the same as before, right? Before we also did this integration using the summation of the rectangles. So let's start with an example. So find the area enclosed by the parabola y is equal to the x squared and the line or the another parabola y is equal to the tx minus x squared. So we need to find the area enclosed by these two curves. Or is it too difficult for you, or is it, or we can start with the easier one, okay? So we will come back to this. So let's do the easier one. Example. So let's say y is equal to x squared plus 1. So and y is equal to the x. We need to find the area between these two curves when x changes from 0 to the 1. Okay? So first of all, we need to draw the two curves, right? So let me draw the curves. So what is the form of this first function? Or let's call this differently. Not like let's call this as a g of x. Okay? And this one f of x. Okay? So this is the simple parabola. Is it different from the simple like x squared? Is it different? What kind of transformation we have to do? We need to make this upper to 1 unit, right? Because we're adding 1 to the y. Okay? So this is simple parabola, but which passes through not from 0, but from 1, right? This will be like this, right? What about the second function? F. So this is simple y is equal to the x, right? Or f of x is equal to the x. So what we need to do is we need to find this area, right? Do you understand? Yes? So this area, by the definition, or we just like to figure out that this area, it appears is equal to above function. What is the above function? Is x squared plus 1, right? Minus the below function. What is the below function? It's simply x, right? And from integrated with respect to the x, where x changes from 0 to the 1. Okay? That's it. So the rest is technique, right? Integration techniques. So the integration of the x squared plus 1, it will be x cubed over 3 plus x minus x squared over 2. We need to put the values from 0 to the 1, or we can just put the values 1. That's enough, right? So this will be 1 over 3 plus 1 minus 1 over 2, right? This will be 1 over 3 plus 1 over 2, okay? Or 5 over 6. The area, this area which is shown in the picture, is equal to the 5 over 6, okay? The idea is, again, so we found out this area by making a lot of rectangles and by summing up their areas, okay? The number of the rectangles now in this case is infinite, okay? So let's go back to our example. So you see, for this kind of problems, the most difficult part is to figuring out what is the integration, right? But integration is difficult as well, by the way. Let's draw this. Okay, so let me write them differently as well. So let me write down this as f of x, and this one is g of x. Right? Okay, so now you need to use your knowledge from the differentiations in order to draw them. Okay, the first one is easy again. This is simple parabola, right? So for example, at the point 1, it is equal to the 1, right? Or let me 1, it is equal to the 1. So simple parabola like this. I mean usual standard parabola, right? The second one is also parabola, right? Because every quadratic function can be drawn as a parabola, right? Now, you can tell me. So I would like to know whether this parabola, the second one, looks up or looks down. Whether this is upward or downward. Okay? So take the two derivative from the g. What is the second derivative of the g? The first derivative is t minus tx. What is the second derivative? Minus t, right? So we've learned previously that if the second derivative is negative, then the function looks downward, right? So this is the parabola which looks down. We made the analysis from the derivatives, right? Now, if it looks down, if it is a parabola, what is the highest point? So this is the first derivative equals to the 0, and you need to find a critical point, right? If the first derivative is equal to the t minus tx, right? T minus tx, what is the maximum point? 1, right? T minus tx equalizes to the 0, t minus tx, it will be equal to the 1, right? So the maximum point is here, at the point 1 and 1, okay? So this parabola will look like roughly like this. It will be like this, okay? What we need to do is, we need to find this area, right? Do you understand this? So the area enclosed by these two curves. Do you understand how we do this? Even if you don't know if you don't have any idea about the curve, you can use the derivatives in order to sketch them. Okay? Good. So this area is equal to integration of above function g of x minus the below function f of x with respect to the x, where x changes from where to the where it changes. So this point is 1, right? We figure out this. So because derivative of this one is equal to the t minus tx, right? G prime of x is equal to the t minus tx. If you equalize this to the 0, it gives you x is equal to the 1. Okay? So from where to where the x changes. So how you need to change the x? From 0 to the 1. Okay? The rest is the simple technique. So we need to integrate tx minus x squared minus again the x squared from 0 to the 1 dx. So what is the integration of the tx? Is simply x squared, right? The antiderivative of the minus tx squared is minus tx cubed divided to the 3, right? So it changes from 0 to the 1. So this will be equal to, if you put the 1, it was 1 minus t over 3, right? If you put the 0, it will be 0 and 0. So this is equal to 1 over 3. Okay? So the area enclosed by these two regions is equal to the 1 over 3. Okay?